Okay, in this video, we're going to take a look at the volume of a pyramid or cone. All right, so the volume of a pyramid or a cone. Now, one thing that we really need to be safe on here is last week we were looking at prisms, right? Prisms and cylinders. And it was just really nice because with the volume of a prism, you find the area of the base and you multiply it by height and you're good to go. This time it's very similar. We just need to make sure that our language is all squared away here. So here we're going to find the area of the base, but here we have a pyramid. All the sides, right, go up to a certain point. And if you watch the little video beforehand, you see exactly how we get this formula. So the formula that we're going to be using for all of these, it's going to be the area of the base times the height, right? Now the height goes through the middle. It's that line that goes right through the center to the top point of the pyramid. And that's the same whether, no matter what the base is. It could be a square, triangle, hexagon. It could even be like a rectangular base, right? So like if I had a rectangular base, right? But imagine that this was a pyramid on top instead of a prism. But no matter what the base is, right? We're going to take the area of that base times the height. And remember now, the height goes straight through the center to the top. It's that line that goes right through the center all the way to the top. That's going to be your height. Now, area of the base times the height. That's good for prisms. For pyramids, we just take the area of the base times that height divided by 3. And that's it. So this should be pretty self-explanatory. I'm going to go over the formulas here real quick. Area of the base times the height, all that divided by 3. I'm going to write down those formulas and do a couple of examples. All right, so the volume of a pyramid or cone. Now, if it is, let's just get to this. The volume of any pyramid or cone, the volume equals, and I'm going to put a big old B there for area of the base times the height divided by 3. The area of the base times the height divided by 3. Now, area of the base, we should be pretty confident with areas of bases, right? Whether it's a rectangle, a square, a circle, no matter what the base is, we should be really familiar with the area of those bases at this point. And then we're going to multiply it by the height, then divide it by 3. Now, the volume of a prism is area of the base times the height. Now, the volume of a pyramid, area of the base times the height, divided by 3. That's the only difference, okay? That's the only difference. And that B just stands for, that big B just stands for area of the base, okay? So we might have to be creative with some of these, like circles. If they give us a diameter, we got to find the radius first. Or if the base isn't a regular polygon, like a rectangle or something like that, okay? So let's take a look at an example here. The first example that we're going to do is this one here. So here we have a rectangular base, and this pyramid goes with a height. Now that goes from the center to the top of the pyramid. That height is 5 inches, okay? So what we're going to do, we're going to find the area of the base, the area of that rectangle on the bottom, which is going to be length times width, multiply it by the height, and then divide that whole thing by 3. And that's it. So the volume for this guy, so the area of the base is going to be length times width. So we're going to have a length times a width times the height, all divided by 3. Okay? So our volume here, length is going to be 5 inches. Width is going to be 2 inches. The height here is 5 inches. All of that divided by 3. So our volume is, let's see, 5 times 2 is 10. 10 times, so that's going to be 50 divided by 3. I don't know what that is right off the top of my head, my calculator. Let's figure it out here. 50 divided by 3 is 16.6 repeating. So we'll say that is 16.67 inches cubed. Now remember, volume is cubes, okay? So 16.67 inches cubed. All right, remember, area of the base times that height, which goes right through the center, all that divided by 3. All right, let's do the next one here. Here we have a cone. Ooh, All right, so the cone, same exact process. Area of the base, which is a perfect circle. On here, it looks like it's a circle. And we're going to find the area of that base times the height, and then the whole thing divided by 3. Now, area of a circle, you might remember area of a circle right off the top of your head. Nice. Pi r squared. So here, again, volume, area of the base, that's going to be pi r squared times the height, which goes from the center all the way to the top, so times the height, all divided by 3. Okay? So our volume, then, we can replace this. What is, we don't know what r is. We don't know the radius of that circle. We just know the diameter, right? And remember, the radius, 2 times the radius is equal to the diameter. Here, 2r is going to be equal to 18 divided by 2. So we now know the radius is going to be 9. All right, so I can get pi times 9 squared times, and now our height here is 18. All divided by 3. And now I can do that in my calculator. So 9 squared. All right, so we get 3.14 times, whew, bless me, 9 squared times, put that in parentheses, times 18. That's some big old number. We're going to divide it by 3. And here we get a total volume of 1,526.04 miles cubed. Like, come on. This is not a realistic example. What cone is 18 miles across at the base, has a diameter of 18 miles, and a height of 18 miles? Maybe that'd be good for like, I can't even think. I don't know what mountain is going to be 18 miles high. That's just so weird. That is so strange. Maybe it's like maybe there's a satellite that's 18 miles over the Earth's surface. Okay, this is a half decent example now. There's a satellite, and that satellite has a cone of like where you can get information. I don't know. I'm trying the best I can. This just isn't a very realistic example.